This video is about using the Cool Cloud app to connect to the Bluetooth newer versions of the Goodman, Franklin, and Amana air handlers with the Comfort Bridge technology. It's a longer video, it's almost 40 minutes long, and it may be a bit much, but if you don't think that you can pay attention to it, stand listening to it for 40 minutes, just commit to one of the four sections at a time. You can fast forward. There'll be a marker for each one of the four sections. One will be connecting to the Cool Cloud app. Two will be systems. Next one will be air handler, and the third one will be heat pump. Those are the different sections that you will have to navigate through in the menus when you are using your phone or a mobile device to set up a Goodman, Franklin, or Amana air handler with this technology. You don't have to use the mobile technology to set them up. It's just a whole lot easier. You can use the three buttons inside with a little LED readout and go code by code by code, setting them up. I wouldn't wish that on anyone, but you can do it if you had to. This video is about how you don't have to do it. You can just use your phone. See ya. Hook up a Goodman Bluetooth variable speed air handler with a Comfort Bridge technology utilizing the Cool Cloud app. Bottom left hand side is of my screen shows the Cool Cloud app. After this video, if you don't have that app on your phone, get it now. Don't wait till you're at an install to have to try to download it and all that. Okay. All right, so go ahead and I'm going to open up the Cool Cloud app. Put in my login. Go down here, clear this out. All right, so we've got the app downloaded. And one thing I wanted to throw in here real quick is connecting to the unit. So I'm going to get through these initial screens, and this is how this goes. This is about how do you connect to your unit. So it's loading things up right now. Come on. It sees our board in our air handler. I'm going to touch on it, and this is what you get. Now it's showing you that you can look through a little hole in the panel on the air handler and get a code, or if you're using a CTK04 communicating stat, you could look up the code on the thermostat. We want to do the method number one and look through the panel. So I'm going to touch pair device by code. Once again, it's telling you to look through the panel. Next. And it's giving you an example of what that code might look like to help you understand what you're looking for. Next. Here it's saying, give me the code. So I'm going to show you where the code is. And I've pulled the panel off because it's just easier. You see that code, 452? That's what you want to use. So go back to the app, put in 452. Done. All right. So I've got a system beside me that is a 2-ton. You wouldn't know that looking at that model number, would you? Sort of interesting, isn't it? But the outdoor unit's a 2-ton. It is ARI matched. First thing you see is we are communicating with it. Okay, we're communicating to the board inside the Comfort Bridge. So what we're going to do now is touch on it. All right. So as it loads the three components, and that's the Comfort Bridge board, the air handler settings, and the heat pump settings. Heat pump for the condenser, right? I want you to take a look at previous work notes and be aware of something. You see my first note? Training. Sorry about derelicts. Enthusiastic adjectives. Well, other people see what you type. And y'all just got to see I can't spell very well. we can joke about that, but if it's just something as improficient, unprofessional looking as misspelling, pay attention to what you put in here. Next one. It says, sorry about Derek's enthusiastic adjectives. Next one. Derek. Tampa is a shit. Okay, great. So we use this unit for live training. We have 8 mobile live trainers that we take around the state. And this one here, we were down in Tampa, had Goodman there doing a class. We brought a guy up, said, hey, he wants to set this thing up, you know. And as he was going through things, he got to this page. He said, man, I'm going to put Tampa's in here. All right, great. And I'm even like giggling, right? What I didn't know, I'm sharing with you right now. Don't do that, because you can't get it out of the computer. The board that's in there, I call it a computer, whatever. You cannot get it out of that board. It will be a permanent record for the customer who, they're pretty smart. They might find the app to get in here because they want to tweak and play. I'm telling you, if they get their hands on the app, or a tech is back there on a subsequent call, he goes in, checks the system out, he's looking at the notes, and the customer's looking over his shoulder. Either way, however it is that a customer can see this, it's unprofessional, and we don't want it to be there. Just the facts. I love being able to put notes in here. Okay. First thing we're going to look at, system settings. I'm going to touch on it. Look to the right, it says no test available. Look to the left, it says test. I don't understand. Why do you have it? I made a call to Goodman yesterday, asked him, and they said because this app is used for more than just the system we're hooked up to today. We might have this same app and be connected to the comfort bridge inside, to the board inside the air handler. And might be that this air handler is that we're on an air handler that is connected to a variable speed compressor. And we will have additional functionality to test. They suggested that maybe even an electronic expansion valve might be driven from this page to test it. But it is non-applicable for us, so we get to move on. Configuration info really doesn't give us anything, so we're going to skip to, at least on this page, we're going to skip to device settings. Device settings, 3 considerations. Set point, satisfy rate. You're simply telling it, how many minutes do I got, boss? I mean, the board's going to be like a thermostat, okay? The board is going to get a call for cooling or heating, and what you're doing right now is you're saying, hey, board, you got 10 minutes to figure this out. First stage, second stage, auxiliary heat, whatever. You're telling it, you only got 10 minutes to make this happen, but it's a bit of an interesting thing to think about. Number one, we recommend using straight cool, inexpensive, basic thermostats. Take advantage of the fact that you don't have to have an expensive thermostat in your quote. A basic thermostat with maybe dehumidification capability and program, can help you be more competitive, and we get that. So if we only have a single stage thermostat, you go, well, how does it control the reversing valve? How does it control first Y1, Y2, W2 in the heating mode, whatever, right? The reality is the logic inside the board and the air handler handles all of it. So you're setting up that board and the air handler right now to be like a thermostat, to make the decisions about when to call in first and second stage and all those things I just mentioned. 10 minutes is my recommendation. And the way it'll work is maybe in the summertime we got a call for cooling. It has not satisfied yet. We'll play make-believe. It hasn't satisfied yet. It's been running 7-8 minutes. And you set this for 10. That board is going to make the decision 6, 7, 8 minutes in. It's going to make the decision, has its own algorithms, and it's going to decide, you know what, I better get second stage in the game. Y2, you're in. Amp up. That's what this will do. It'll make the decision to intelligently keep you in the lower stages as long as it can, but still satisfy the stat. No more than the number of minutes that you've set it for here. Move on. Backup heat lockout. Because we have a challenge of line sets running through chases at sea level. A remarkable amount of line sets running through water. And you think I'm joking, measure them. Measure the temperature inside and out. You might be shocked. So here's the deal. I do not really want to prevent my electric heat from being available to that 10-minute request up above. Thermostat says, I'm in heat, I've already got Y1, I've brought Y2, I'm still not happy, man, I got another minute or two before I'm supposed to be done with 10 minutes, let me get the electric heat in here. I don't want to prevent it from happening. And setting this at 65 degrees means, hey board, you can use the electric heaters all the way until it gets 65 degrees outside. And at that point, dang it, you got a problem if you can't satisfy the house. Allow it to bring the electric heaters in if it needs to. So I set it up to 65, and that is the warmest setting. Okay. In climates where you don't have line sets going down below that could be in water, say if the line set's going up and over, I'll play. If it was going up and over where water's not a challenge, I would reflect back onto a balance point chart and make my decisions where, you know what, it shows here my heat pump should be able to keep up with the house's needs all the way down to about 30, 35. So heck, I don't want to pay the power company for them. So you may just set this thing to 35. If lines are going up and over, that's how you do it. You'd use a balance point for them. Balance point to figure it out. I'm going to tell you, lines under the chase in Florida with the water, 65. Compressor heat lockout. What are we saying? We're saying, when do we want to shut off the compressor? When are we going to say that the compressor cannot give us enough heat to be worthwhile spending the money to run the power bill, to pay the power bill to run it? I'm going to cut to the chase on this one and tell you that I don't really want to prevent my compressor from giving me heat if I didn't have a substantial amount of electric heat to begin with. For example, we see 5 kW go in homes all the way up to 4 tons in this climate. And they're thought of as supplementary heat to help the heat pump. But the reality is, if we have to have emergency heat, they're not enough. And we really don't think about them for that purpose. They're just undersized to handle that role. So they're only sized to augment the heat pump. They're little bitty heaters. And the reality is, you got a little bitty heater, and you got a heat pump that has diminished output because it's running through water. Yeah, I'm stuck on that thing. We're talking about the vapor line running through water. So in my mind, I simply don't want the outdoor unit to shut off because, man, there ain't enough electric heat in there to really heat by itself. I've just been defaulting and setting it to 0. It's never gonna get to 0 down here in Florida anyway. And truly, I don't want the compressor out of the game because I just don't have enough heat in the electric heaters. So on cold days. So 0 degrees, just set it there. Easy enough. If you made any changes now, you'd hit apply changes. All right, we're done. I didn't change anything. So device status. Here it shows you what the equipment's doing. Here it says HVAC operation mode, idle, off. Humidification, dehumidification, ventilation mode, off. Great. Then you go down to the 24 volt. T-stat, W terminal off, Y terminal off, Y2, D-hum terminal off. It's simply a tool for you to know, is there volts coming from that stat over there? Maybe you got a system that won't shut off. You're trying to figure out why. Well, right here, you don't even have to get a meter out and see, is a dang thermostat sending me a signal and it shouldn't, or is my low voltage shorted and the cause of why this blower keeps running? Or you can simply look at this to find out, are you getting 24 volts in these terminals? Shared data. All right, my unit's already been set up, but when you do an install, you go down here, you can take the use the camera feature, okay, And you could zoom in on the little cubie there and click on it, and the camera will capture it, and then it'll look it up to see does it have the latest shared data. You can do it that way. I've tried to do it right here in the classroom on our training unit. For some reason, it doesn't want to use the camera to initiate that step. So what do? Well, I had to manually enter the unit information. So if I touch on that page, it brings up all these units. And I've got a AVPTC 31 Charlie 14BA. You see it all the way on the bottom of the page? I'm going to touch it. And shared data for the selected model number will be loaded. Please confirm the following physical characteristics. And it's asking you, is this for sure what you got? Well, yeah. Confirm and continue. Warning, this will reset any previous settings on the unit. Do you want to proceed? Yes. So it's just going to go through, and it has to be able to come out of the Bluetooth mode now and get to a Wi-Fi, which brings up another subject. It'll use your cell service to get to the internet. But what I would recommend is, if there's Wi-Fi in the home, to have already connected to it prior to beginning this. Now, it says that it was a success. Remember it said it would change all the settings? Oh man, I don't understand why they don't have this setting at the very beginning. Because let's go see, it said that it's going to change all the settings. Does that mean it changed everything we did a minute ago? Let's go back to device settings. Set point satisfy rate back to 30 minutes. Think about what I just said. It should have put that firmware update right at the front, shouldn't it? But it didn't. And it kicked out all my settings. I think that's a bit of a goof up on the layout of this, and I want to share it with you. So before you do all these steps, the 10 minutes, the backup heat lockout at 65, the compressor heat lockout at 0, before you go in here and set any of this up, how about you skip right down to shared data before you begin any of these pages? Okay, literally what that would look like is you go back here and you've been at this page. How about we do this? Excuse me, Corona. All right, how about we do this? We go through each one of these real quick, open it up, go to shared data, and we do that step. Manually enter the info here, and you enter the air handler. You go through each one of these things. Do that first. Then come back to this first page, AVPTC 31, and do each page individually to set your settings. Just to show you that, air handler, shared data at the bottom. Probably ought to have set it to begin with. So you had two places to do it. Okay, I saved my changes. Air handler, device settings, meat and taters, here we go. Constant fan airflow multiplier, 30%. In other words, fan's only going to run at 30% of whatever you set the full CFM up to. In this case, we have a communicating system. So the outdoor unit's a 2-ton. It's already told this board, hey, I'm a 2-ton, 400 CFM per ton. You're going to move 800. It defaults that way. So 30% of 800, if you're geeky like me and you want to do the math, that's 240 CFM. I really don't care about it. What I do care is that I don't want to pay the power company just to run the fan. The less speed you run it, the less it's going to cost to run, the quieter it's going to be. Well, constant fan airflow, what is that? That's when you turn your thermostat from auto to on, just because you're in that shoulder season. You don't need any air, don't need any heat, but you're trying to filter the air, run it past a UV, things like that. Electric heat, kW. This thing doesn't communicate with the heaters. There's no magical, communication to your heaters to tell this thing what your heaters are. You got to tell it. We have 5 kW. Done. Electric heat, airflow, trim. Leave it at 0. We'll get into that more later on, but the length of the conversation is not worth the effort we put into it. Just set it at 0. Electric heat and heat pump airflow multiplier. Well, when I'm running my heat pump and my electric heat, I want this thing to kick up and go faster. Here's the deal. We only got 5 kW. I don't care about this. if I had 10, especially 15 or 20 kW set up in here, I want to make sure that this thing ramps up and gives me some extra airflow across all those heaters. Otherwise, we might flirt with tripping the temperature limits if we don't have enough air. Okay, maybe not in the beginning, but the first time the filter gets a little bit dirty, bam, we start tripping limits. So when you've got more kW, you may want to enter more airflow. So what are your choices? Well, I can add up to 10%. Not a big increase, but you have that option to go ahead and do it. Remember, when you turn anything up, you're increasing static and you're increasing noise. You may have a high static duct system that just simply can't tolerate you doing anything to crank this thing up even more. All right, done. Electric heat on delay. I don't want any delay on my electric heaters. Okay, so I see no benefit really to delaying the blower when the electric heater turns on. Electric heat, what's that? That's your emergency heat. Okay, so electric heat off delay. What are your choices? I'm going to set this to the lowest setting, 30 seconds. The reason for that is we're saying, okay, electric heaters got turned off. We were in emergency heat, and that's the whole point. And when the heater's turned off, there might still be some of that heat energy you paid the power company to produce up in the ducts. Let's go ahead and get it out of the ducts and get it in the house. I don't want to run this longer seconds, okay, because there's a point where the return air, I don't know, let's say it's 70, 72 in the heating mode. The return air comes in and it's warmer than the temperature of the air in the attic, in the ducts, outside of the ducts. And you actually start giving up heat energy that was in the house to loss of the ducts to the cooler attic. So for me, I want to minimize this whole thing. I'm going to just take it and drop it down to 30 seconds. Done. Dehumidification logic, high. Simply put, we are accustomed to almost all the systems out. The way dehumidification works with regards to slowing a blower down if the humidity gets too high, the way that works is the humidity gets 5% above the set humidity, and it triggers an action. What is that action? A normally closed set of contacts that was given a connection between red and the thermostat to the dehum terminals inside your unit saying, here's power, run at full speed blower until I take this power away. If you are setting up a thermostat to do that for you, they interpret that as a high setting. If you choose low, it's a different logic. Low would be you have a normally open set of contacts going to dehum. Nothing's being fed to the dehum terminal. And if the humidity gets too high, it will close the contacts and send power to the dehum. And then the board inside interprets that and goes, all right, let me slow things down. We don't use that. Not here, but I wanted to share it with you. We use the high configuration. Apply changes, done. Heat pump. Okay, well, you have a test page here, and we can talk about that later, but I want to set things up first. So, configuration info, if you wanted to look at it, it just tells you that here's your equipment. I sort of like this because it does confirm you're communicating with the outdoor unit, and it can see it right here. Okay. Device settings, meat and taters. Unit tonnage. Right now, because it's communicating, if I touch that, it doesn't give me any choice to move anything. 2 tons is all it is because it's communicating with the outdoor board. It knows what it is. But if you didn't have this thing wired to communicate, 2 wires is all you need. It's just so smart to do this if you have the option to do it. Communicating is the way to go. But if for some reason you decided you just want to hardwire this thing, maybe your guys just don't understand some of this, they fear it or whatever, you have the option to hardwire it to the outdoor unit. And if that's what you did, instead of communicating, you would have to change the tonnage and tell it what you got. Done. Cooling trim factor. I like in new construction that we stay on point with setting a unit up for 400 CFM per ton, and I get a lot of heat from folks that will say, man, you do better when you got 350. Dehumidifying, it's a humid climate. I get all that, I really do. But I don't want to start out that way on our installations. A couple things I think about is when we design the duct system, we're designing it for 400 CFM per ton. And if we lower the blower, we are lowering the blower. Okay, we are flirting with maybe not hitting some of those furthest rooms the way we want to. So that's number one. Number two, if you look up the target dry bulb temperature in a lot of the common apps, including like JobLink, which we use a lot of right now, to say, hey, what temperature should that air be? That's based at 400 CFM per ton. There's currently no mechanism there like some of the other apps to say, no, man, I'm going to set this for 350 CFM per ton. How cold should that supply air be right now? And the app will tell you. Don't have that. I want techs to judge the equipment. Look at the supply temperature and tell me, is it what the target says? And unfortunately, the apps we're currently using only know how to give us a target at 400 CFM per ton. So we're going to leave it alone. But later, should we want to lower it from 400 CFM per ton, I can subtract. I can either add 10% or I can subtract, if I want to dehumidify better, 10% off of the 400. So what would that be? 400 minus 10%. That would be 360 CFM per ton standard airflow. So I have the ability here to trim it back. All right. Going to go ahead and leave it alone. Put it back at 0. So we're at 400. Just wanted to share that with you. Cooling airflow profile. For new construction startups and even our installation changeouts, our changeout, I want to go ahead and leave this on A. Thermostat calls for air, blower runs at its full speed. Okay, when the thermostat's happy, blower shuts off. That's what profile A is. We'll do another video on understanding the profiles later on. Right now, leave it in A. Blower on delay in cooling. So you get a call for cooling, the outdoor unit gets told to run, it starts, and here, what do we got? Blower on delay, cooling. It's set for 30 seconds. That means that the coil will get nice and cold. Okay, great. And then it turns on after 30 seconds. I'm okay with that. What are our choices? 5 seconds? Well, it's going to delay just for 5 seconds. I think that's sort of meaningless. I sort of like the idea of getting that coil nice and cold so that we can load it with moisture faster and get the dehumidification game going on. That's my 2 cents. Don't think it matters a whole lot either way, but if I can do a little more to get a head start on the humidity game, I'm going to do it. So 30 seconds, I'm down with it. Okay, blower off delay in cooling. I wished I could set that to 0. There is no 0 choice, so I set it to 30 seconds. If the cooling is off, the outdoor unit's off, but the fan keeps running, you will inherently re-evaporate moisture from that coil, put it back in the house, raising the humidity. There are some units that have 60, 90, people with a minute and a half. The longer the delay, the customer will typically have a colder set temperature. And you walk in their house and they got to keep it 70 where they could have kept it 72 or 74 because of the discomfort with the higher relative humidity that you get from reintroducing that moisture back in the house. Set it to the lowest setting that you have. In this case, it's 30. Dehumidification enable. I'm going to leave it off for the purpose of this video. If you wanted the dehum function from the thermostat to be able to go, hey, I'm humid in here, let's slow the blower down, you would simply turn that on. Right now, I'm going to leave it off. Reset fault history. No, I don't ever want to reset the fault history. I want to know everything that's ever gone on. Heat pump heating trim factor. So in heating, you can adjust the blower. If you have older folks that had a gas furnace up north and man, these heat pumps don't put out any heat, you could lower the blower by as much as 10%. Bring it down to that 360 CFM per ton. I don't like doing that. You get exactly the same amount of BTUs of heat no matter what you do. It's just the sensation is hotter or cooler, depending on turning this up and down. It's a sensation. Man, it feels hot coming out. That's great. Thank you. The reality is we have one reason why I don't want to change this from the 400 CFM per ton, and that is we teach a simple rule of thumb to really evaluate how's my heat pump doing. Nobody ever checks the heat on a heat pump. They're always worried about a split in cooling. But there was a very, very reliable rule that I was taught that I share with folks called the 32-20 rule. And you can use the formula to figure out, hey man, it's 22 degrees outside. What should my split be if this thing's working right? And you can figure that out. And then you can compare it against what it is doing to make a decision. How's my unit doing? It's based on if you're moving 400 CFM per ton. If you go screwing with the airflow here for heating, you can't use that rule. You have no idea what the split should be. So I'm going to leave it at 0. Blower on delay. So your heating turns on, but we let the coil get warmed up for 15, 10, 5 seconds. I'm okay with this because it's going to get the coil hotter before the blower turns on and maybe minimize the cold draft sensation, okay, of the purging of the cooler air in the ducts. It's going to have a hotter temperature coming right behind it quicker. So I'm okay with that. Defrost interval. Every 30 minutes, you set it for 30 minutes. As an example, think of those jumper pins on a defrost board. Well, I set it for 30, 60, 90 minutes. What does that mean? It means that, let's say we set it for 30. Every 30 minutes, it's like a clock. We're going to say, okay, it's been 30 minutes. Let me put my shoes and shirt on and my cap on. I'm going to go out there and take a look at that sensor on the coil and see if it's cold, if it's got ice on it. Is it below 29, 30 degrees, whatever. So it's just saying how often do you want to take a look at that outdoor temperature sensor to see if you got ice on it so that we can get the defrost going. All right. I'm going to leave it at 30 minutes. Reason being for that, by the way, is if I set it for a longer interval, that means that sensor might have been freezing its butt off. It might have been 25 degrees out there on a unit that maybe has some sort of problem. And it isn't even recognizing there's a problem that it's super cold. As far as defrost is concerned, there might be an inch of ice all over everything. But because the clock hasn't come and looked at it, it hasn't gone into defrost yet. There's other factors in defrost than that, outdoor ambient for one, but we're going to leave that alone for now. Okay, so we've got compressor delay. What is that? When you go into defrost, what 3 things typically happen? You should know that answer. What 3 things happen? Shuts the fan off on the outdoor unit, switches the reversing valve to cooling, and turns on the electric heat, because you just turn it into an air conditioner when you put it in cooling, and we're going to try to minimize that cold air, temper the air a little bit for the homeowner. Well, there's a 4th thing now. And the 4th thing is it shuts off the compressor. Y'all ever heard a unit go into defrost? It goes whoosh, round, 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 generates all kinds of service calls. My unit's blowing up. And you have to think, it probably wasn't real good for the compressor when you think about it. Hot discharge gas getting hammered for a second right into the suction side of the compressor, because that's really what happens when the valve switched. Here, when it goes in defrost, it shuts the compressor off. And that whoosh, well, it happens, but you don't get all the noise and the compressor trying to run, getting its butt beat, whatever. Quiet is the main thing. So for 30 seconds, pressure's equalized, the other 3 things are happening, and then the compressor goes down and fires back up. So you're saying, how long do I want it to delay? Do I want it to stay out of the game 0 seconds? What does that mean? It means it ain't going to shut off. Round, round, round. That's what you're going to get. You can set it for 5, 30, 15. Okay, so I'm going to leave it at 30 seconds. Everything's equalized. It's ready to get back in the game. Nice and quiet. Done. Apply changes. We didn't change anything. So we're going to roll on. Almost done. Device status. Once again, it's telling us what requests are coming from the thermostat. All right. Or in this case, forget that. What requests are coming well, thermostat was part of it, but are coming from, in this case, the outdoor unit. The outdoor unit is what requests the airflow. Okay. Dehumidification comes from the stat. So here, heat capacity request, heat capacity provided, cool capacity request, cool capacity. What does it tell them? Capacity requested, first or second stage. It'll tell you here, 50% or less for first stage, and anything above 50% for second stage. Sensor data. You got two sensors. Outdoor temperature. It's a little bitty thermistor that pokes itself out. Looks, a little black thing pokes out from the area where the low voltage and high voltage hook to the condenser. That's at 71 degrees. That's what we're reading right now. Coil temperature. That's the temperature of the coil. We use that temperature to tell the defrost logic that comes around every 30 minutes. Say, hey, are you cold? We tell it what temperature we are. Now, I'm not sure what the temperature sensor is on this. I need to read up on it, but I believe let's just use 29 degrees as an example. When it gets down to 29 degrees, if that clock comes and checks on it every 30 minutes, it's going to realize, dang, we got to do some defrost. Fault code history. These are the fault codes again for the outdoor unit. Okay, it's got all the codes listed. You can look at active ones while it's running to see, is it doing it right now? Nope, they're all in the history. They were back in the past. Now, I'm going to go ahead and go to the top left, hit the back button. We have completed everything we need to do to set our system up.